There is a graveyard of dead stars in the Milky Way galaxy that is striking in size. According to a new study, astronomers found ancient stellar remains when they first mapped our galaxy, which formed about 13 billion years ago, was home to billions of stars. Over time, many of these massive features became dense remnants. When a star more than 8 times larger than the Sun burns through its elements and collapses, the outer layers of the star explode into a supernova. Meanwhile, the stellar nucleus a condensarea is either a neutron star or a black hole. Modern neutron stars and black holes formed in the Milky Way are easier to detect because they remain within our galaxy and correspond to its shape. But the ancient stars that existed in the young, developing Milky Way galaxy were like stellar ghosts as researchers tried to find them. The very supernova explosions that caused the stars to collapse actually threw them into interstellar space. The researchers determined that 30% of these stellar remnants were completely ejected from the galaxy, according to their research published in the latest issue of the journal Monthly Notices of the Royal Astronomical Society. The research team was able to map the location of stellar remains inside and around our galaxy by recreating the life cycle of ancient stars. One of the challenges in finding these ancient objects is that until now we had no idea where to look, said study co-author Peter Tuthill, a professor in the School of Physics and director of the Sydney Institute of Astronomy at the University of Sydney. In Australia, in a statement, the oldest neutron stars and black holes were created when the galaxy was younger and of a different shape, and then underwent complex changes over billions of years. Simulating it all to find them was a major challenge. It was like trying to find a mythical elephant graveyard. The bones of these rare massive stars were supposed to be there, but they seem to be shrouded in mystery. Researchers have faced many challenges trying to trace the steps of ancient stars and their violent death agony. Supernova explosions are asymmetrical, and their remnants are ejected at high speeds, up to millions of kilometers per hour, and worse still, this happens in an unknown and random direction for each object, said lead study author David Sweeney, a doctoral student of the Sydney Institute of Astronomy, University of Sydney. Knowledge of magnitude was not enough either. The team also had to simulate the behavior of the stars and the orbits they can reach after a supernova explosion. There was also no friction that could slow the speeding stellar remnants. Almost all the remnants that have ever formed still exist, sliding like ghosts in interstellar space, Sweeney said. A new map shows where the stars were born in the Milky Way, where they exploded, and where their eventual repose took place.